Brilliant. Thank you all for coming. And it sounds like the sound's all working, so it's great. And I'm really pleased to see there's some people in the front row. Some places I go, you get empty front rows. So thank you to everybody who sits in the front row. I enjoy it. So every event, everywhere, all at once. This talk exists because all of the terminology around events can be a bit discombobulating, as in confusing, making you feel a bit anxious. And so this talk is going to be a disambiguation, so that you're a lot happier with all of these different terms, and you can go back and sound like you know what you're talking about when you get back to work. So people will think, great, we can send them to more conferences. So this is a good talk. So I'm Jacqui Reed. I'm the author of Communication Patterns, which is published by O'Reilly. And if you want to find me, have a look at my website. I am an independent consultant, so I go into businesses and I help them with their software architecture, knowledge management, and kind of related areas with enterprise architecture as well, things like that. So back to today. This was originally going to be an A to Z, but most of the terms actually begin with E. So it's not a very interesting A to Z. And so what could I do instead? Every event from everywhere, all at once. And if you've seen the film with a similar name, you might see a few things that you might like in this, but you don't have to have seen it, so don't worry about that. So we're going to look at things so that we can build on our previous knowledge rather than just going from A to Z. It's going to be a lot easier. And so where better to start than what is an event? A lot of people think they know, but there's actually quite a few definitions out there. If you look in the dictionary, you get ones like an occurrence, something that happens. So that's very high level. They're saying something happens, but they're not saying kind of when it happens. How about a prearranged social activity? This is the type of event that we see the most as humans. We do these all the time, but it's actually, this can be the thing that really confuses people between computer events and these events, because these are actually calendar events. Now, these might be things like a party, best kind of event, surely, apart from a conference. It might be a medical appointment, it might be a flight or a train, but it's all about time. It's all about when it happens. Now, the biggest difference between a calendar event and a computer event is that a calendar event can happen in the past, it can be happening in the future, and it could be happening right now, like this conference or talk. So let's look at another one. An end result, an outcome. Now, this is probably the closest dictionary definition that you will get to what a computing event is. So I'm going to give you a nice umbrella, high-level term, a definition for you for computing events. It's something that has happened. And that's the really key thing here. It has happened in the past. It's immutable. It's not going to change. Now, events, don't worry, you don't need to read this. There's not going to be a test. Events have been around for quite a while, since before they became popular with event-driven and distributed systems. Now, we've got an example here from the Java world. So here we've got an event object, and this was introduced in JDK 1.1, which came out in 1997. Winamp came out in 1997. Who remembers Winamp? Oh, I knew a few people. Look it up if you don't. So, don't tell me if you weren't born in 1997, but I'm sure there were people here who were in school in 1997. So, we've got lots of different subclasses here. A lot of them related to the UI, but we've got a couple that are to do with changes. And I want to have a quick look at one of these so we compare these events from yesteryear with now. So this first one here, we've got the preference change event. Now, the biggest difference here is that it's in the present tense rather than the past tense. So that's one difference there. It also says that it can be that something's been added, removed, or changed. Now, typically now, we would model that with 3 different types of event, unless they're all in an aggregate, but I'm not going into aggregates. You've got to talk later on that, the deep dive into aggregates. I'm not touching it. So we're actually modeling 3 different events here, and that can cause some issues, which we'll talk about in a minute. So if we scroll down here, we can see here's a thing. This one is similar. We've got state encapsulated inside this event. So in this case, we've got a key which identifies what's been changed, and then we've got our new value. But the other thing we've got in here is the logic, so that we can work out whether this is an added, a removed, or a changed. Now, all of the consumers that consume this event have now got to put some logic, this business logic, into their code. And so we've actually got a form of coupling here because we haven't split this event out into the different types. So all consumers, whether they are interested in, they might only be interested in it if it's been added or if it's been removed, but they've still got to consume the event, work out whether they want that event, and then do something with it. So we've introduced a bit of coupling there, and that's why we tend to break these things down if we know that our consumers aren't going to want all of this information. So, moving on. Next thing I want to look at is the difference between events and commands. So we've looked at the dictionary definition of events, but now I want us to understand the difference between these two, because it's fairly important when you're designing your systems. So commands and events are both types of messages, and messages are about getting information from one place to another. So let's see how they differ from each other. We've got this message parent class, if we're thinking about object-oriented programming. Let's look at the command first. So this is an intention. It's being sent to one or more services, modules, whatever you are using. But we're having this intent, we expect this thing to be executed. We expect that preference to be changed. But you can't guarantee it will, because of course, whoever you're sending this command to might fall over. It might say, you know what, no, computer says no. So we need to handle that. Now we can send commands to more than one consumer, but we're then increasing our transaction boundary. If we need all of those services to all act on that command or all not act on that command, you're going to be looking at retries and rollbacks and things like that. So our command there, we would call it something in the present tense, change preference. So that's our present tense command. Now, if we look at events, we've got our event producer, and it's a fact which it publishes. It goes, this happened. And then it goes, do what you want. I don't care. It doesn't know necessarily who's consuming it. It doesn't care if you do anything with that information. Of course, you can't guarantee that anybody's going to be doing anything with it, but it doesn't care. Now, we can have different transaction boundaries when it comes to events as well. We're using something like a broker, and we'll look at this a bit more later as well. But these events are named in the past tense, and so here we've got preference changed. So we've got those two differences, the two different things here. Now, Oscar, who's here as well, he likes to use this one in a blog post about the difference between events and commands. So you've got the intent of the event and of the command, and then you've got the result of the event. Now, this is quite a nice way to remember it, but another thing to consider is that we can call this a fact instead of a result, because we need to remember that it's going to be immutable. It has happened. We can't change that. Things in the past have happened. We may want to change them, but we can't. So that's a nice way to remember it. Now, we can look at something so we've got a work item here in a to-do or sort of ticket management system. So if we had a command of create, that would give us a work item with a state of to do, and the event would be work item created. And then messages, I said these can be lots of different things. Here it's, I like creating work items. I don't like completing them, but I'm quite happy to put them on a list of things to do. So that's the first one. And then when we've got these other different commands, we can say, right, we're going to start this work item. Now it's in progress. Work item started. Doesn't really matter what the message is at the moment. And then when we complete the work item, we have a state of done, not to done, done. And then we've got work item completed. So there's the difference, the different comparisons. And of course, as I said, these are all different types of message. So a command is a message, but a message is not necessarily a command. We're thinking in the sort of parent and child classes. Moving on, we've got lots to look at today. Event listener and event handler. Now, you've probably heard these terms used interchangeably with each other. It's very annoying, but they tend to refer to the same thing. But we can break them down a bit semantically so we understand it. So we've got a listener. Now, this is listening for an event. So hooray, somebody named something appropriately in software. How did we manage that? So we've got a listener, it's a subscriber, it's listening for one or more particular events. And when it hears those events, I'm going to use the word hears because, it's nice and easy to understand, it's going to trigger a callback function. Now, sometimes this callback function gets called a handler in itself, which is where we get a slight confusion. But this function is then going to do something as a response to that event. And it's going to do that asynchronously to the listener. And then this whole thing we can call the handler. So there, you've got your listener and you've got your handler. Easy. Next, event streaming, a slightly more complicated one here. We are looking at continuous flows of information, and we are aiming to act on this information in near real time. So let's have a look at this. With use cases for streaming tend to be analytical things. This is where you maybe have a batch process that runs overnight, and you want to change that into some kind of real-time dashboard or similar. And so for this, we need an event streaming platform, and we need some APIs, which will be used to push information in and pull information out. And so you're going to have some producers, and they are going to be pushing events into this platform. And you've got things like IoT devices, microservices, anything that you need to be saying, this happened, this happened, this happened. Then, on the other side, you've got your consumers who subscribe. And so this platform in the middle is going to reliably record these events and push them out to the subscribers. So we've got things like OpenSearch and data warehouse, things like that. Now, what it's doing underneath that is it's using a message log. And so we have a producer producing our logs. And I thought, what example am I going to use here? And I thought, oh, Star Trek, they're always creating captain's logs. So we're going to have a few captain's logs on here. So our producer is producing our captain's logs, our events, putting them into this stream. And what they have is this thing called an offset, sort of an identity. And that offset is going to be used by consumers to read those events from the stream. Now, they're not removed from the stream once they're read, but they can be removed because they usually have some kind of lifetime. Someone might have set that lifetime for 50 years, so it could be infinity, it doesn't matter. But say it might be 30 days. And so these consumers are recording that offset, either say every X events that they've read or every Y seconds. They're going, right, that's the last one I did. Now, if one of those consumers then has kind of a bit of a problem, if you're in the Star Trek world, maybe they encounter Q, for anyone who likes Star Trek. When that service comes back up again, it needs to look at its last offset, and then it's going to start consuming again. Now, the other thing to consider with this is that consumers don't necessarily start from the beginning and work their way through. They might want to take, say, a selection of 10 or 100 and do some sort of analysis on that. But when this service comes back up, it's going to start reading again, depending on the last offset that it recorded. But maybe it had actually processed or partly processed one of those events and had to go back a little bit. So you need to be thinking about idempotency. Your code needs to be able to handle processing the same event more than once without everything burning and falling to the ground. So consider that, because things do not get removed off of these streams. Now, that's streaming. I want to also talk about message queues. These are not used in streaming, but it's important to compare them with each other. Now, there are actually some products which are starting to offer more than one of these now. So if you've got a product that's offering both, you definitely need to be thinking about which one do I need. So message queues, slightly different. We've got a producer, which is adding things onto the queue. Queues popped up again there, not that kind of queue. So we've got our consumers. These are going to be taking things off of the queue. Now, this is one of the differences here. When a consumer successfully processes one of these events, it gets removed from the queue. And if one of these consumers says, I'm going to process that, but then never acknowledges it and never says, I did process it, then that event will then become available again on the queue for another consumer to consume. So here we've got two different consumers here. It's called competing consumers. It's one of the patterns that you can use if you're going to be using multiple consumers here. And so those are the big differences between the message log and the message queue. Important to understand. Now, I said we were going to be building on our knowledge. Now we're going to look at event-driven architecture, or EDA, and this can use streaming, it can use message logs, it can use queues, because you can use message logs without using streaming. It's just the way it's implemented. So, EDA. First, I'm going to show you where it's not event-driven, where we're going to look at command-driven first, so we can see the differences. So say you've got a distributed system here, lots of different services here, and they're going to be using commands. Now, when you're using commands, you are addressing them to a specific place. Maybe it's an API, but you are talking to these services. Now, we can see who's talking to whom on this diagram. Very useful. This could be done via the message queues as well. Via an event bus as well. But we've still got coupling. And of course, you never have a completely decoupled system, because if you had a completely decoupled system, you wouldn't actually have a system. That's kind of what a system is. But when you've got commands, you're more likely to end up with changes affecting other parts of the system, all these different services. And so, of course, we can do things like we can do the like backwards compatibility, things like that, things like consumer-driven contracts as well, and that all helps with this type of thing. But when we are looking at an event-driven, so that was the command-driven, now we've got the event-driven. Now we're looking at publishing and subscribing via a broker, that kind of thing. Now, this can be via the streaming, via the queues, but we might think, oh, wait a minute, we've got this broker in the middle, what happens if that goes down? Now, there's lots of things you can do with that. Some of them can run serverless, but you can have more than one instance to help with this. But the big difference between these two diagrams is that first diagram told you who was consuming what. This diagram doesn't. This just tells you that people publish and subscribe stuff. And so when we look at these event-driven systems, you're going to need to be thinking about knowledge management because your diagrams do not show all the information that a command-driven one shows. And the thing with these distributed systems is that whether they're command or event-driven, they are basically like a wall of ivy. If you imagine that all these strands of ivy are the data flows, it's being hidden by lots of things behind these leaves. As you get further away, it's harder to kind of see where this information is going. So you are going to need some real kind of world-class knowledge management, and I'm sure everyone here has lots of documentation and knowledge management at their companies. So you're really going to need that when we're looking at event-driven systems, any kind of distributed system. Right, the one with sticky notes. This is the fun and colourful one. This is a very useful technique, and I want to show you why you might want to use this. But first of all, what on earth are all these different coloured stickies? We'll look at big picture event storming, which is the kind of the highest level. It's the one you're most likely to come into contact with. Now, these orange ones are events. You now know what events are. Done. These ones are opportunities, these green ones. And that's where you've gone, oh, we might be able to do something better here. We might be able to take advantage of something. Then we have these pink ones. These are hotspots. This might be where people disagree about what happens or what should happen, or maybe you've just identified a problem. And then these are normally turned 45 degrees. It makes it more obvious for everyone, especially people who might be colorblind. So that's one of the reasons why we have different shapes as well as different colors. Now, these little yellow ones are actors. The blue ones are where you use them to vote on what might need attention next. So when you've mapped things out, you then can say, right, where are we going to focus on this hotspot, this bit here, or this opportunity? And you use these votes. And it's a good idea to get people to put their initials on there, because if you need to discuss it afterwards, you can see who has actually voted. And then these pink ones, these are systems. Now, I'm going to show you an example, because showing you a legend is pretty useless. So you end up with things like this. Things are absolutely huge. People cover walls like this with these sticky notes. And what you're doing here is you're bringing together all of the people with the knowledge, and you're getting all that information out of their heads. So you're breaking down these silos that you might have within the business. And if you run one of these, you'll find people going, oh, I didn't realize it did that. Oh. So it's really interesting to break all this down and to find these kind of pain points where people say, this really just doesn't work at the moment. And other people in the business will go, oh, we thought it was fine. So you're bringing people together. It's really good. Now, let's look at a quick example. We've got ship docked. We're staying in a Star Trek at the moment. Then resupply started. Again, these are in the past. Then resupply finished. And this is all in the space station stores. And then someone said, oh, wait a minute. Should we be actually thinking about the different stock types? Do we need to worry about the different types of supplies that we're putting on here? Do we need to go deeper into this? And this brings us nicely on to the next one, which is a pivotal event. Now, these are kind of the most important events in your system, and these are the candidates for the boundaries in your system. So when you're working this out, you might use these to break up your services or modules or whatever you're doing with your design. Now, once you've identified them, they're normally indicated by this yellow line, quite often done just with tape when you're doing this on a wall. And these are going to be the events with the most people interested, because you're going to find the people in one group and the people in another group, both kind of one group is producing this event and another group, or more than one group, is going to be consuming this event. And so you'll get people having arguments over what things should actually be called. So that's one way to identify these. These are going to be where the rules of the game change. So maybe you discover that when your order is shipped, so it could be called order shipped, at that point your order becomes immutable. And so the rules of the game have changed there. That's probably going to be a pivotal event. And because of this, you're going to find these different bounded contexts within your systems. And between these bounded contexts are where these pivotal events sit. And because of that, you're going to end up with these extra models which translate between a model in one of these systems and another. And we're going to talk a little bit more about this a little bit later. So event storming comes in 3 delicious flavors, my favorite of which is chocolate. No. So the first one is big picture. We just talked about this. And with this, it's discovery-oriented. You're getting a large group of business and technical people together. You're discovering what should happen or what does happen. So that's what the big picture is. Then we've got process modeling. Now, this is when you're going down a bit deeper, and we're thinking about trying to design things. And you're going to have a smaller, more focused group for doing this. Then there's also the software design, and this is either going to be technical or it's going to be kind of user experience focused, and you're going to get these smaller groups who are even more focused on these different areas. So that was event storming, the one with the stickies. People tend to like that one. Right, event sourcing. Up until now, we've been talking mostly about events as getting information from one place to another and communicating. This is about storing events, which of course is another form of communication. We are storing the information and then we are reading it. So, storing events this time. Now, again, I'm going to do a comparison for you. So, stateful is where we have things like relational, we have document databases, and these store what ends up being the current state, because when things are added, things get overwritten. And we might have a last updated date or a star date like this, but what we have is the current state. If you need to know what that data looked like at 2:30, 3 weeks ago on a Tuesday, you are going to have to be digging through any kind of logs that your database has and hoping that you can recreate it so that you can sort out that bug that happened then. When it comes to storing sourced entities, we're storing all of the changes to that data. And what you can do then is you can apply all those changes to any point in time that is stored to recreate that data at that point in time. It's a little bit like time travel. And so what this is it's a history of state. Now, most of you have probably used version control, things like Git. It's basically like that. You are storing the state for every change, every state change that happens in the data. And that means that you can go to that point in time that you want. Okay, another overloaded term in technology is the term stream. We talked about streaming earlier. These are event sourcing streams. Different. This is why we need this talk. So, in event sourcing, a stream is all the changes to a particular entity or aggregate. Now, it's also good practice to not have too many events in your stream because of performance. And so what happens is you end up with lots of different streams for different entities, but also for the same entity. And what you do is you split them up. So maybe you have lots of events are recorded each day. So maybe you split it every day, maybe even every hour if it's an awful lot of events. Or maybe it's not that many events. And so this is to do with like accounting or something. And so we want to split it monthly or yearly, that kind of thing. And so we split these up. Now, when I send out the slides, there's going to be lots of further reading for all these different bits, because of course I can't go in depth in any of it. So there's some further reading on that if you're interested in it. So here we go. We've got a couple of our streams here. And then what we do to get the latest version is we then apply all of these different changes to build up the information that we have. And what we can do is access these things. It depends on the database, but some of them will use things like projections and read models. And you can build up an external cache of this data as well if you need that, if you need something really quick. And so we've gone through, we've applied these different things. As I said, if you want more information on that, have a look at my further reading links. Got to move on, got to get through all of these. So, event store. This needs disambiguating because some people will call any store of events an event store, and some people will refer to a particular one. So, when you are storing events, you can use a generic database. You can roll your own. You can use products like Martin and MessageDB, and they provide sort of wrapper around Postgres so that you can use that as an event store. You can also use the very specific databases which are for storing events, and one of those is called Event Store DB. So this is a bit like the term Hoover. We've got Event Store DB being the actual name of something, and then we've got Event Store being the generic term for a store of events. And one key thing here is that it's write once, read many. Because remember I said that events are immutable. They're in the past. So we're writing once, we're reading many times from our data stores. Moving on. This one is not as depressing as it sounds. A tombstone event. So, in programming, a tombstone is generally a marker for this data is no longer there. Now that sounds quite high level, but again, we need it to be to cover all the different places where it's used. And this is very useful for things like C++, where if you had a dangling pointer, that could cause severe memory problems. So it would be pointed at Tombstone instead. Now, Tombstone events can be used in different ways in different places, but they generally do still mean this data is no longer there. So, in event sourcing, tombstones are often used as markers to show the end of the lifetime of one of the streams. But they can be used differently in different places, of course. So Event Store uses it to mark a stream for deletion. It's saying, right, we don't need that anymore. Whereas in other places, it can be used to say, oh, just don't use this anymore. Let's delete our projections that we made for it. Then Martin uses it in a different way. So if you've got a failed transaction like that one there, it will try and put a tombstone in. And the reason it does that is because it wants to not lose out on that identifier there. It uses global identifiers throughout the whole thing to for ordering all of its different events. And so it kind of falls over a bit when it's trying to create projections if those aren't there. So it's trying to sort problems out with it. So we've got two different ways here, but still they generally mean this data is no longer there. With Kafka, so now we're looking at streaming, this can use it in a different way. So there is a pattern here called the maintain order of redirected events pattern, which isn't very snappy, but actually it does describe what it is. So I like this name. So what happens is Kafka may have an event and it goes, oh, I can't process this for some reason. I'm missing something else. So it puts that event onto the retry queue. And then that retry queue is going, can I do it now? No. Can I do it now? No. If another event in the same, with the same kind of identifier comes along, it will then put that into the retry queue as well. And the reason for that is that it's stored the identifiers of the ones that it's put on the retry. Now, when the retry successfully actually does that event, it then creates a tombstone to say, success, which sounds really, really odd, doesn't it? I've successfully processed this, so here's a tombstone. But what it's saying is, this data is no longer here. I've processed it, this is fine. And so the main Kafka app looks for those tombstones and removes those identities going, okay, that's fine. So when that third event in that same sequence comes through, it knows, oh, I don't have to put that on the retry queue because I've seen the tombstones for all the previous ones to it. So there you go, another different way of using tombstones. And this one, I think, this is one of those kind of edge cases where it's almost a command. Because remember when I said that commands, you have an expectation for something happening. And so we've got the retry going, oh, here's a tombstone, I've finished processing this. So this is one of those really kind of borderline, is this a bit of a mixture here of commands and events? So there you go. I told you it wasn't as depressing as it seemed. Now, this is a really good one. Domain and integration events. These are really, really confusing because people just don't seem to know what's a domain event, what's an integration event. And interestingly, in the DDD Blue Book, there is no domain event. It came out after that. Now, it is in the Orange Reference Book, which you can actually download from Eric's website for free. And so with this, he says, something happened that domain experts care about, a representation of something that happened in the domain. And so domain events are things that the business cares about. They're business events. Some of our events are really kind of low level that we use in our code, but higher level, we're talking about things that the business cares about. So you may have heard of domain events as those being ones that tend to run in process, or at least within a domain, or we're talking really about a subdomain here. And then we need these integration events to communicate between our domains or subdomains. But if we apply Eric's definition here, integration events are also domain events. They're probably actually the most important domain events, because as I said before, these are the events that are linking everything together, that everybody's interested in these events. And so this is where we get all of this confusion. Now, I want to give you some different terminology for this. And the first thing you need to kind of think about is when we design our events, if we think of them in the same way as we design our APIs, then we're going to do a lot better. Now, I'm going to talk about Oscar again here, also Nick, he's here today, and they both agree with me on this. They say we don't have domain and integration events. APIs. We don't have domain and integration APIs. We have public and private APIs. So when we start thinking about it in those terms, we can say, look, all of them are domain events. They're all business events. We care about all of these things. But the ones that are inside our domains, that maybe if we make a change, it doesn't make that much difference because it's all contained in one team, these are going to be our private events. And then those ones in between, they're going to be the public events. So our public events, they're going to need to have this shared model in between. So we're going to need to be thinking about backwards compatibility. We're going to need to think about versioning, these kind of events. But the private ones, just like our private APIs, we can just think of those as, oh, we manage these locally. Other people aren't going to be using these. It's not going to break production if we make a change to our private events. If anyone is consuming them and it breaks production, then that's their problem, isn't it? Surely. Right. This leads us really nicely onto event granularity. Now, I've talked about events and what types of events they are, whether they should be public or private, but what should we actually be putting inside of events? How much data should we be putting in there? And there's a really good answer to this. If no one else has the slide with this on at this conference, then I'll be disappointed. So, but what does it depend on? So what we should really be asking is, What does it depend on? So we've got a continuum that we can think of here. It's not like the Q continuum in Star Trek. That's another plane of existence. We'll leave that alone. But we've got less data and we've got more data. Now we can think of things on one end of the spectrum as notification. This is where it's just saying, oh, this happened. Here's the identity of something that changed. And then when we get to the other end, we're providing lots of context, like this changed, and here are some other things to do with it as well. When we're in the middle, this is kind of a status. It's like this changed, these are the items that changed, this is what is new. So when we're in this part of the spectrum, we're in what's called event-carried state transfer. And all that means is the consumer doesn't need to call back to the producer for more information. They've got all the information they need. But why do we even need to care about this? Can't we just shove all the data in there and then people will be fine? They'll always have what they want. The trouble is you always get trade-offs with any of this. So if we're at this end of the spectrum, the very small end, Oscar likes to call this a clickbait event. So you get that event, and you can't do anything with it unless you call back to the producer. And it's pretty useless, really, because then you get all of this latency of having to call back to the producer. The producer then has to do something and find that information and send it to you. And what if that producer's now down? You can't get that information. What if that data's been overwritten? Yay, it's gone. So lots of downsides to a clickbait event, but there's also lots of downsides to what I call an all the things event, where we put everything, including the kitchen sink, in there. Not only is there all the processing and the storage for all of that data, but you are creating coupling, because there are going to be services that are consuming this that only want a couple of those bits, and then other services want another couple of them. So if you change any of those items, you could be causing issues in multiple services that are wanting those. You also get the problem that the tell, don't ask, which I hate that, because tell and ask mean they're too close together. But tell, don't ask means that whoever has the information should be processing that information. So if you give everybody all of the information, they're going to start putting their own business logic in and go, oh, we can calculate that value here. We don't need to ask for it now. But then the business rules change, and you've got duplicated business rules, and these ones are out of date. So don't give people enough rope to hang themselves. That's a good term for it. Oh, give them this much rope instead. Then they'll be all right. So we need to think about where we are on this continuum. Now, we generally get told, make your events as small as possible. But that's how we get to that clickbait event. So really, we should be making them as small as possible and as large as necessary. What you're really trying to do is get this event-carried state transfer so that when a consumer consumes an event, they don't have to then call back and go, oh, but can you tell me when was the last time this updated? Or can you give me this other value? You want to design your events so people don't have to do that. Now, it doesn't mean that your consumer's not going to have to talk to someone else to do whatever they need to do, but you're cutting down on all that latency with the network traffic. Now, you were all just thinking there's not enough events. Not enough events in this world. So I'm going to give you a bonus one as well. And this one is called the non-event. Now I'll show you what this one is. What were you expecting? It's a non-event. So today we have gone on a huge tour of all of these. I've thrown in another couple of terms in there as well. And this is all to try and help you to just disambiguate between these things. Now, I can't say that I have done all the events. I can say maybe mostly all of the events, because people keep making up new terms, things change, and I only have 50 minutes to talk to you today. So for anyone who's keen to learn more, have a look on my website. There's lots of training options, consulting and things like that, which I offer. And just because you're special and you are here at KanDDDinsky, I've got a code for you. So if anyone wants me to come and run a workshop for them, you can get 20% off a workshop. So all you need to do is just contact me via my website. So have a look on my website. There's a few blog posts and stuff on there that's interesting as well. And I will be giving out these slides probably via social media. So you can get all the further reading and all the information you want. So thank you very much.